Hey everybody, this is Mr. Beckstrom, and today we're going to go over section 3.10. This is derivatives of inverse trigonometric functions. It is just about as exciting as it sounds. So just like for all the normal trig functions, we also have derivatives for all of the inverse trig functions. Some of them have restrictions here. For example, if we're looking at the cosine, remember the y values of the cosine function can only go between -1 and 1. So for the inverse function, it's the x values, and so on and so forth. And the same thing for sine here as well. So both of those are included in this one. For the tangent and cotangent, we can go from -infinity to +infinity. And for the inverse secant and inverse cosecant, we can only look at values that are basically either greater than 1 or less than -1. And another way to write that is just the absolute value is greater than 1. All right, and then we also have the derivative of the inverse function. So here it says let f be differentiable and have an inverse on an interval I. So that basically means that it's continuous over that interval, because in order to be differentiable, it also has to be continuous. It's differentiable, and it also has to be 1 to 1. Why? Because the inverse exists on that interval. And if we have that, then basically what it's trying to tell us is that the slope of the tangent line at the reverse point, so for example, if we have a point xy on the function f, then the point yx on the inverse is going to have a slope that's equal to the reciprocal of our slope for the normal function there. So we can just put 1 over that slope to get the new slope for the derivative, not the derivative, the inverse, excuse me. And we should be taking a look at an example of that as well. So let's go ahead and get started here. I have a problem here, and it is, and remember to use the chain rule where applicable. So if something's in here other than just x, like here, we have 1 over x, then we have to apply the chain rule. So go ahead, see how far you can get, or set it up, and then when you're ready, unpause the video and we'll go through the solution. Alright, so it looks like we have this function up here, but instead of x, we have 1 over x. So not only do we need to put everything here and replace this x with 1 over x, but then we're also going to need to multiply by the derivative of 1 over x. Now let's do that off to the side here, just since we know we're going to have that anyways. So the derivative with respect to x of 1 over x, that's the same thing as x to the -1. Well, that's just going to be equal to -1 times x to the -2, which is just equal to -1 over x squared. So that's going to be the derivative of 1 over x is -1 over x squared. So now that we know that, let's go ahead and solve this. Well, I need to at least leave that formula up there. So first I'm going to do this. Now remember, we have to replace the x in here with the 1 over x, so it's going to look like this. So the derivative is going to be equal to -1 over the square root of 1 minus, remember we have to replace that x with 1 over x squared, and then we have to multiply by the derivative of the inside function here, because we have to apply the chain rule. We already know the derivative of 1 over x is -1 over x squared, -1 over x squared. And then we simplify that a little bit, and we're going to get a +1 all over x squared times the square root of 1 minus, and we can write this as 1 squared over x squared, which is just 1 over, kind of ran out of room here, x squared. And you can leave it just like that. Now, in the book, they have a slightly different answer. What they did was they combined these under subtraction, basically x squared over x squared minus 1 over x squared, to get x squared minus 1 over x squared. And then they pulled the x squared on the bottom out, which becomes x, divided here, and they left it as the absolute value of x. Why? Because we're going to have to get a positive answer since we're squaring this x here. All right, so let's take a look at another example. All right, so here's the next one here. It's the inverse cotangent of 1 over y squared plus 1. So why don't you take a second, try to set that up, see how far you can get. Remember, we're going to need to use the chain rule again, and we'll unpause it when you're ready for the solution. All right, so I know that I'm going to end up using this cotangent formula right here, but I also know that I'm going to end up needing to use a chain rule, so I'm going to have to end up finding the derivative of this. So I'm going to do that off to the side right away, just since I know that's going to need to come into play. If you want to wait, you are more than welcome to do it. That's just how I like to roll here. And I'm going to rewrite this. Instead of 1 over y squared plus 1, I'm just going to write that as y squared plus 1 raised to the negative 1 power. I'm going to bring it on top. Makes it a little bit easier. That way I don't have to use the quotient rule. I can use the chain rule instead for that. So using the chain rule, it's the derivative of the outer function. So it's going to be negative 1 times y squared plus 1. Subtract 1 from negative 1, so you get minus 2 times the derivative of the inside. And that's going to give us times 2y. And cleaning this up a little bit, I'm going to end up getting negative 2y all over y squared plus 1 quantity squared. All right, so that's the derivative of the inside of this one. So now let's go ahead and get this going here. Give myself as much room as I can. So the derivative with respect to y here, that's going to equal to, we're going to use this form here, so that's going to be negative 1 over 1 plus, remember, the x squared, you just have to replace whatever's in the function here, so we're going to put that whole thing in there, 1 over y squared plus 1 quantity squared. So this is the derivative of the inverse cotangent of some angle here, where the angle here is squared, as you can see here. And then we're going to have to multiply this by this over here, by negative 2y all over y squared plus 1 quantity squared. All right, so let's go ahead and clean this up a little bit and solve it. So the negatives will cancel out. So on the top, I'm just left with 2y. And on the bottom, I'm going to have to distribute this down here. So it's going to be this times this. So 1 times that is just that. So that's going to be y squared plus 1 quantity squared. And then plus, and then this times this. Well, this is really 1 squared over y squared plus 1. So that's just y squared plus 1 quantity squared. So these are going to actually cancel out, just leave us a 1 here once you do that. And let me just do that off to the side in case I'm confusing you at all. So I can rewrite this one as 1 over, well, 1 squared over 1 squared plus 1 quantity squared. And this is times y squared plus 1 quantity squared. So that's going to cancel out, just leaving us with the 1 squared, which is 1. And this is your final answer here. All right, let's take a look at one more. All right, so for this last one, we have f of s is equal to the inverse cotangent of e to the s. So here, I mean, it's the same thing if you replaced x with s. You could do that too if it makes it a little bit easier for you, but our independent variable for this one is s. So how do we do this one? So go ahead, try to set it up, solve it if you can, and then we'll go through the solution. All right, just like before, we're going to use this formula here, except wherever there's an x in here, we're going to replace it with e to the s. So f prime of s is going to be equal to negative 1 over 1 plus, and this is e to the s squared, and then we are going to multiply this by the derivative of e to the s. And remember, the derivative of e to the s is just e to the s. So this is a pretty easy one here. So we clean this up a little bit. So I'm going to have a negative e to the s on top, and on the bottom I'm just going to have a 1 plus e to the 2s. Remember, if you have an exponent to an exponent, you can just multiply those together. And that's it. Make sure that you try some more of these. If you have any questions, please let me know, and I hope you all have a great rest of your week. Thanks.